Up to this point, we've delved into the diverse functionalities of the server, encompassing OData, EF Core, API, identity, and more. What's next?
Firstly, we'll delve into dependency injection. In the Microsoft tutorials and other resources available online for Blazor, MAUI, and ASP.NET Core, services are typically registered within the program.cs file. However, in boilerplate, to prevent overcrowding in the program file, service and middleware registrations have been delegated to partial files.
What if we need to create and register a service that functions seamlessly across both Android and web platforms?
While it's possible to add it to both the web project's program file and the corresponding file in the MAUI project, this task often lacks efficiency. This is where the iService collection extensions files come into play. They enable you to add and register services in any project you prefer. If a service is implemented and registered and shared, it won't have direct access to ASP.NET Core, Blazor, or iOS facilities. However, it can be utilized across all projects. On the other hand, if a service is implemented in the Android folder within the MAUI project, it will have full access to Android features and can call Kotlin and Java code, but it will be exclusive to Android only. As a general rule, if a service isn't required on the client side, it's advisable to implement it on the server to avoid increasing the app's download size. For code that needs to be universally accessible, the shared project is the optimal choice. Conversely, if a code base must be available across all clients, the client core project serves as the most suitable location. Additionally, you can establish a base class in both the client core and shared projects and inherit from it in other projects. For instance, the exception handler base in client core facilitates common exception handling tasks across all clients. However, if we wish to log errors using a platform-specific tool like App Center, is it appropriate to add its NuGet package into the client core project? Given that this tool isn't compatible with web clients, adding its package to client core would unnecessarily inflate the web project's download size. Instead, we can leverage the MAUI exception handler to incorporate App Center within the MAUI project and utilize it within the MAUI exception handler class.
Got it. The next question, should we consider deleting any unnecessary projects?
You can delete the infrastructure as code, IAC project if Azure isn't being utilized. Additionally, the MAUI or Windows projects can be deleted. However, the server, web, shared, and client core projects have distinct significance. In production, the server project not only serves API and identity functionalities but also facilitates the execution of the web project in Blazor server and auto modes, and is responsible for pre-rendering. Therefore, if you require any of these three functionalities, you must also deploy the server project where an ASP.NET Core project can operate. Furthermore, as you've witnessed, Blazor server offers an optimal developer experience, making it imperative to adhere to the server project. Naturally, if your intention is solely to deploy Blazor WebAssembly without pre-rendering in production, a common requirement, you can toggle the Blazor WebAssembly standalone value to true in the directory build props. Subsequently, you would publish the web project instead of the server project. In this scenario, you have the flexibility to place the output files of the web project anywhere, without the necessity for the server to support ASP.NET Core. For example, these files could be hosted on Cloudflare pages, GitHub pages, or Azure static pages. Your code remains consistent across all modes. Only the app.razor file on the server side is inactive in this mode, and the index.html file from the root directory of the web project is utilized. If you have modified the app.razor file, ensure to update the index.html file accordingly. It's important to note that enabling Blazor WebAssembly in standalone mode when not PWA features has several drawbacks. By activating Blazor WebAssembly standalone, the PWA setting is also automatically activated, albeit PWA can slightly impede the development experience in debug mode within the development environment. Hence, it is recommended to configure the Blazor WebAssembly standalone value to false after completing the testing and publishing the web project. Additionally, you have the option to exclude the API components during project build. This ensures that the server project is built without EF Core, controllers, and identity functionalities, focusing solely on Blazor Server, Blazor Auto, and pre-rendering capabilities. Suppose you have a distinct server project, not developed using bitplatform, and it may not even be based on .NET. For instance, it could be developed using Python Django. To enable the client project to connect to your existing backend API, you can specify its address in the appsettings.json file of the client project.
Although we've delved into the client structure in these recent episodes, I believe it's time to shift our focus to the client exclusively. I look forward to seeing you in the next episode.